So we're going to start out by talking about the frequently made mistakes for assignment number 3. And a lot of people really had problems with this. So I'm going to go through many different mistakes and talk about what some of the problems were. And hopefully this will give you a better idea of how to address them. But make sure that you go back and fix all these issues, because otherwise you're going to get marked down substantially. So first of all, make sure you document your code. There seems to be a correlation between people who have code that doesn't work and people who don't document their code. People who document their code seem to be just a bit more attuned to understanding what they're doing and explaining it. So make sure you document your code, otherwise you'll lose points. Lots and lots of problems with the constructors and basically the rule of 5 constructors, so move constructor. There were problems with copy constructor. There were problems with the move operator. There's problems with the move assignment operator, the copy assignment operator. And that was a little bit befuddling to me, because we had gone over these things in pretty great detail when we were going through the generic programming videos. And if you go back there, there are basically 6 videos that talk about generic programming, and I walk through how to implement the rule of 5 features in great detail. So it was rather strange that people were having such a hard time, because we'd actually walked through many examples of how to do that. So I think I left you some comments, but just generally make sure that you go back and rewatch those videos and look at how I was implementing the various copy constructor and copy assignment and move constructor and move assignment and so on. And that should give you a lot of tips on how to implement this code. Now, obviously, it's not 100% the same, but it's very, very close. So one thing to do, whenever you have the base member initialization section, make sure that you actually do something in it. Don't just do what is done here, which is to initialize it to nothing. You've got to give it a value. Otherwise, it's going to be initialized to some arbitrary random number, which is not what we want at all. That'll give you very strange bugs. Also, just a good habit to get into, make sure you use null pointer here instead of 0. 0 is not technically wrong, but it's better to use null pointer to make it clear what you're trying to do. Another thing, in the default constructor, don't set the marray field or data member to new array t of size 0. Just set the array data member to null pointer. That's all you need to do. It's very simple. Make sure that you don't format the base member initialization section so it just runs off to the right. You can see here that this is hard to read. Instead, format it the way I do it in my code. So if you have any questions, there's lots and lots and lots and lots and lots of examples that I've done to illustrate how to do this formatting, and please try to follow that convention. Down here, the person's trying to allocate a scoped array. First, you don't need to allocate a scoped array. You just need to allocate the array, and it'll hold it in the scoped array, because marray is a scoped array. And secondly, if you were to do this kind of syntax, you're not allocating any memory in the scoped array, so it's not going to have anything to hold. So that doesn't make any sense. You shouldn't have to put try-catch in your code. That's the whole point of using the scoped array, is to avoid having to have a try-catch in your code. Please, again, go back and rewatch the extensive videos on this subject where I talk at length about why you want to avoid putting try-catch into your code. And we actually had a quiz question about that recently as well. So this makes no sense. The person is, I'm not even sure what's trying to go on here, but they're initializing the scoped array to the value that's being passed in. That's not the point of a scoped array. Please go back and watch the discussions about unique pointer, which is basically what your scoped array is, and you'll see how that gets used. And there's also other things missing here. Make sure that you fill in all of the data members in your base member initialization section. And then down here, something is missing as well. That was all the code there. And if you think about it, that's not going to create an array and then copy the contents of value into every element in that array. That's not going to work because there's nothing there. This code here, poster child example of writing non-exception safe code. This is about the worst thing you can possibly do. Don't ever, ever, ever allocate naked pointers or pointers that are raw pointers, better term, raw pointers. Never do that, because if an exception is thrown, then you're going to leak memory. And the whole point of the assignment operators and the copy constructor and this constructor is not to leak memory if exceptions are thrown. So make sure you do not do that kind of stuff. It causes major problems. This code has a huge bug in it. You need to allocate memory in the copy constructor. That's the purpose of the copy constructor, is to allocate memory. This is going to have an aliasing problem, and I don't even want to think about how horrible this is going to turn out to be. Also, please try to use Stl algorithms wherever you can. We've been talking about a bunch of these things. Even the ones we haven't really talked about in length are easy to understand once you know the trick with algorithms in Stl. So whenever you're starting to do things like writing a loop to copy a value into every element in the array, that's what fill does, or fill n. So get in the habit of using those methods. You'll see down below that I also want you to use the copy algorithm instead of having a loop. So start getting in the habit of not writing loops anymore when you can be using the copy algorithm instead to be cleaner. And especially don't be writing index-based loops like we're doing here. Those are really prone to bugs because of off by one errors. Again, as we've talked about over and over again in class, in many videos and many sections, always use the base member initialization section. There's no excuse for not using that at this point. If you're not using the base member initialization section, either you're not watching the videos or you're not understanding what we're talking about. So go back and watch the videos, make sure you come to office hours, make sure you ask questions, but don't not use the base member initialization section. It's there for a reason. This particular code is also just incorrect. The purpose of the move constructor is to essentially lobotomize the source, or the right-hand side, the thing that you're creating the left-hand side from in this case. And in this case, it's not actually doing that because it's not removing the ownership on SRC. Now you've got aliasing, which is bad because you'll have double deletions. So please go back and rewatch the videos that talk about that stuff. If at any point in time you have questions about what we cover in the videos, ask them on Piazza, come to office hours. Don't just sit there confused about what's going on. I'm a little bit dismayed at some level at how some people are just not availing themselves of the resources in class. And it's clear because the assignments are reflecting the fact that they don't know what's going on. So there's lots of opportunity to get help, and we're here to be helpful. So please leverage that wherever you can, and don't be confused. Let's see, this code has another problem where marray is being set equal to some nonsensical value to begin with. Don't do that. You shouldn't be doing that in this case. This code is also not exception safe. Start getting in the habit of using the copy algorithm whenever you are tempted to write a loop that copies the contents of one array to the other. And of course, do it in a way that's exception safe. This is not exception safe. And using the STL will not save you in this case from the lack of exception safety. So please make sure you're handling that properly. Here is another problem with a copy constructor. Actually, I should probably move this up just a tad, since I was trying to keep all my copy constructor stuff in the same general vicinity. So in a copy constructor, you don't need to check whether or not the address of S, or source, equals this, because the left-hand side doesn't exist. That's the whole point of the copy constructor. So that's an unnecessary check. It's never going to be true because you can't possibly be doing things like that. Nice. Please mute yourself, by the way, so that you're not interrupting the lecture. So also, please use the STL copy algorithm here. Again, get in the habit of using that rather than using the loops. And as you know, we've talked about that. I've shown you lots of examples of using the copy algorithm and how it's implemented. Okay, now, I should take it back. Yeah, so this is fine. Let's now go down here. This is also in the wrong place, so let's put that up a tad. Okay, so now we're back into move constructor land. And this code is buggy because the swap that's being done is swapping uninitialized data members. So M-array, M-size, and M-capacity are not given any values. They're just given random values, no values. And so as a result, when you swap, then there's going to be problems because the thing that you're swapping out of is going to end up being given uninitialized values, which is not at all what you want to have happen in this situation. They need to be set to basically null pointer and other things so that they don't blow up in an unexpected way. I'm not really sure what this code is trying to do, quite honestly. It doesn't look right. I'm not really even sure how it compiles, but it's not the way you write. I don't think it's the way you write the move constructor. Here was something a number of people were doing. They were allocating memory in the move constructor. And of course, that totally defeats the purpose of the move constructor. The purpose of the move constructor is to transfer ownership from the parameter that's passed in to the object it's being moved into or initialized. And so you don't want to be allocating memory because that memory is going to be deleted immediately. And so it's, as you can see here, the M array is being initialized to a dynamic array, and then immediately down here, we're releasing it, which makes no sense. So don't allocate memory, don't do copy operations in the move constructor. That's not the purpose of the move constructor. And it's also unclear why clear is being called here. That's going to cause all kinds of problems because we just, I don't want to think about what's going on. So down here, make sure that you use the base member initialization section. Otherwise, things are going to be really strange when you try to do the swap because you haven't actually initialized M-array. So M-array's got some garbage value, and now you're trying to swap through a garbage value. So that, I don't want to think about how horrible that's going to be. Don't have loops in the move constructor that are copying the contents. That defeats the whole purpose of having a move constructor. The purpose of the move constructor, again, is to transfer ownership. So please make sure that you're transferring ownership and not copying anything. And then down here, don't make the call to M-array reset in the body of the constructor. Initialize M-array with the release of the source's M-array. That's the way you need to do that in the base member initialization section. All right, so as you can see, many problems with move constructor and with copy constructor. Go back and watch the videos. I talk about these things at length, show them over and over again. So it's your responsibility to make sure that you're watching the content and understanding it. If you have any questions, don't hesitate to ask. Now let's get into problems with the assignment operator. So the code here is got all kinds of problems. First of all, that's not the way to check for self-assignment. We talked about that in one of the recent quizzes. You have to do it a different way. So go back and take a look at all the code I've written and shown you as examples to see how to do a check for self-assignment. And this code also is too complicated. It's not exception safe. And I believe it's also got a memory leak as well. So it's just chock full of bugs. And do not write the copy assignment operator like this. The copy assignment operator should always be written in a very straightforward canonical way. And if you go back and watch the videos, I show you how to do that. And it should always look exactly the same. Never should deviate pretty much for any reason at this point. You should always use the same pattern for writing the assignment operator, the copy assignment operator, that is. Also, make sure that you check for self-assignment in your assignment operators in the canonical way. And this code is way too complicated. It's not exception safe. It's way too complicated. Go back and do it the one true way that's needed to write the assignment operator. Now we're into the section of the move assignment operator. So again, much like the move constructor, the idea here is to basically transfer ownership from the left hand to the left-hand side from the right-hand side. And this code is just incorrect and is inefficient. So there's too much stuff going on here that doesn't need to be here. This code made no sense. I wasn't sure what it was trying to do, but I don't even think it should compile because it doesn't make sense to move the object into the array. So again, go back and watch my videos on generic programming. It shows how to do this kind of stuff. Always make sure to check for self-assignment. This code leaks memory. We're just overwriting marray unilaterally. There's much cleaner ways to do this. Still problems. This doesn't check for self-assignment. It's too complicated. It's not exception safe. And so again, lots of problems. Please make sure you fix that. Now we're getting into the part of the code where it's out of the boilerplate land of the rule of 5 kinds of operations. And now we're really getting into the heart of implementing the semantics of the array list. So a couple things. You can greatly simplify your code by making this add method, the one that just takes a const tref and adds it at the end of the array. Don't have any logic in there other than just calling the other add method with the index being the current m size. So that just takes away a whole raft of bugs and extra complexity by just forwarding to another method. So this method, this is the add method where the real work gets done. And I recommend here that you create a resize method or a check internal size method. You can decide what you want to call it, but basically this method should ensure that the array has enough space in it to hold the item you're trying to insert at that index. And so it's going to magically grow the array if necessary in order to make sure there's enough elements. And a lot of people had very complicated code here, which could be simplified by factoring out a helper method called resize or check and grow if necessary, or whatever you want to call it. And you just always call that method to make sure that it's got enough space. And then the code becomes a lot simpler because all you do is you call this internal method. It's a private method that you can add yourself. It's always okay to add private methods to the assignments. And when it comes back, you know that you've got enough memory. And then you can just say, marray sub m size equal, marray sub index equal value. And that's all about writing code that's properly factored. There's also, I saw a number of people do stuff like this. They allocated a new t and then dereferenced it. That's just going to leak memory, so don't do that. If you want to allocate a default t, just say, marray sub I equal t open close paren. That's a more effective way of doing that. Also, just as a rule of thumb, you should try not to use for loops like this, but instead you should make sure that you use loops that have, or don't use loops, instead use the copy algorithm or the fill algorithm. By the way, here's another problem. Notice how I didn't even notice this at first glance, but this should be basically uint32 underscore t, because that's the type that we're using to index into the array. So don't be putting, whenever you start finding yourself being tempted to put casts in your code like this, resist that urge, because a cast means something's broken, just like in real life. This code also has all kinds of problems. It's not reallocating memory. In fact, it's not allocating memory at all. It's just making the capacity larger, but not resizing anything. So got to rethink that one. Your code will have all kinds of memory leaks and problems there. Now, this is also some weird stuff. So there's a difference between the subscript operation and the get operation. The subscript operation doesn't do range checking, but the get method does, and the set method does. So make sure you do range checking. And we'll talk in a second about how to set up range checking properly, but you need to make sure you do range checking. Another thing that was bizarre is taking the address of marray sub index. You don't need to do that. This is going to return a reference, actually a const tref. So you just have to say marray sub index. You don't need to be taking the address. And I'm surprised that this code even compiled. Maybe the unit test didn't exercise that path, but it's definitely not correct code. You don't need to check to see if the index is less than 0 in any of your checks, because it's an unsigned quantity. That's what u means in uint32. And so as a consequence, it could never possibly be less than 0 because it's unsigned. And therefore, you don't need to check for that. Down here, a lot of people, I'd say almost everybody, maybe everybody initially, were replicating checks in their code to see if the index was in range. Using the guidance of the don't repeat yourself principle, the dry principle, you should never write the same code over and over and over again, especially if it's sort of low-level, easily error-prone code. So instead, what you want to do is have a method called check range or range check, or throw exception if index not in bounds, which is probably too verbose, but you get the point. You should start getting in the habit of factoring out that repeated low-level code into nicely named methods, and then call those nicely named methods. And that'll be much more effective at being able to make your code easy to understand. So just factor that stuff out, call it whatever you want, and then use it in your code, and just make it a private helper method. This particular code, I think, will cause infinite recursion because you're implementing operator subscript on an index in terms of a call to operator subscript on an index, which is obviously going to cause problems because your code will recurse infinitely. When I see code like this, it probably indicates that the person didn't run the unit tests, or if they ran the unit tests, they didn't stop and figure out why the unit tests were never finishing, because this will go and actually, I take it back. It'll finish. It'll keep recursing until the program blows up because you've exceeded the stack depth. So make sure that you don't write code like that. The next thing we're going to talk about is remove. And in this case, again, make sure you refactor the check for the bounds check of index into a check range method. And lots of problems with people's remove calls. This particular one was really odd. They were deleting marray subindex. I can't even begin to imagine how that would compile, number one. And number two, the damage that would do to the runtime environment in C++ is just staggering and disturbing to think about, because you're basically deleting something that's not necessarily allocated dynamically. It's just bizarre. So make sure that you think carefully about how you're going to remove something. And we've talked at various points along the way about how STL does this kind of stuff. You basically remove things by copying over the element. And that will then go ahead and trigger the appropriate cleanup if anything is necessary with the assignment operator that you're copying over top of. So think about that. And also make sure that you're careful in using copy or fill wherever you can in the implementation of remove. Is empty. This is a little bit too belt and suspenders. You just need to check to see whether or not size is equal to 0. You don't need to check if capacity is equal to 0. You don't need to check if marray is a null pointer, and so on and so forth. Just check if size is equal to 0. This is probably the wrong check, whether marray equals null pointer, because it probably shouldn't. You can have things that have been allocated where marray is not equal to the null pointer, but the array is still empty. So make sure that you carefully check that and do the right check here. Also, lots of weird things in clear. Clear really is just going to kind of be like a callable destructor, if you will. Its purpose is to free up the memory and set the various data members like size and capacity back to 0. So it just kind of says, reset this thing. So it doesn't make any sense to go through the array and release. I'm not even sure what that would do. I'm not even sure how that would compile, but it's not the right thing to do. This implementation of clear is missing something very important, so we're going to end up leaking memory if you do it this way. So please don't do it that way. Definitely do not delete marray. Marray is a scoped array. The purpose of a scoped array is to take control of memory deallocation. And you can either do that when a destructor is called, or you can do that by explicitly calling the release method on the scoped array. But don't delete it, and definitely don't delete it as an array. Again, this is doing untold damage to the runtime environment of your C++ program. So please, please, please don't do that. Let's see. Oh, here's a get. Here's a get that snuck in here somehow. That probably should be up here. Let's go put it where it belongs. And here we go. So this get implementation doesn't check the range properly, and you don't need to use operator subscript. Just subscript. That's the whole point of subscript operators to make it look like you're accessing a built-in array. Lots of problems with set. Set should be sort of the equivalent to get. It should be really simple. You should do a range check by calling a check range method or whatever you want to call it as your private method and throwing a out of range exception if you need to. But then the rest of the code should just be sort of a one-liner where you're basically setting the index with the new value. No need to copy things, no need to assign anything. It's way, way, way too inefficient. This particular implementation of swap is really weird. So it looks like we're trying to swap array lists rather than swapping the elements of the array list. And I think this will generate a recursive call. At least it'll do something very weird. So don't do that. That's not what we want to do. You want to swap the elements in these objects, not the objects themselves. This one doesn't do enough swapping. This code also doesn't do enough swapping. It's incomplete. I'm not even sure what it's trying to do, but it's not correct. This code here is too complicated. Just use the swap method. You don't need to do a release and a reset. Just use the scoped array swap method, which you wrote for an earlier assignment. And again, in swap, don't be going through the elements and swapping them. That doesn't make any sense. You're just trying to swap the pointers, and you'll be swapping M size in both elements. You'll be swapping M capacity in both of these array list objects, and you'll be calling the swap operation on scoped array. So make sure you get all those things squared away. And this code is just too complicated. Just use the swap operation. The MArray swap is fine. The other things, you don't need to define all these other variables. That's the whole point of swap. So I think the couple of big themes that stick out here, make sure you're watching the videos, make sure you're following along, make sure if you have any questions, you're coming to office hours or posting questions on Piazza. Don't just sit there passively in a state of confusion. That's not helping anybody. We're here to help you. We want you to do well. That's why the whole course is set up to have these reviews so you get better. But that there's a responsibility that comes with that focus on quality. You have to be proactive and take advantage of these things. Also, always be thinking to yourself, how can I write clean, elegant code? And how can I be leveraging patterns, and how can I be leveraging other elements? And you'll really see this once you have the iterators implemented for the next assignment. Then you can start really cleaning up the code. It'll get very, very, very beautiful in assignment number 4 if you do it right. Okay, so that's what I wanted to cover. Let me go ahead and take some questions because I see some questions have come in. Do we still need to do the self-assignment check in the move assignment operator if standard swap is used to swap anything? Yeah, because there's no sense in going to the trouble of doing the swaps if you can just check real quickly to see if the pointers are equal. I could see it going either way, honestly. I'm not, it's probably microscopic in the difference, but it's just a good habit to get into, I think, to have your move assignment and copy assignment operators just always check for self-assignment. If you do that, then it just makes life easier, and it's probably a good habit to get into, even if it's sometimes unnecessary. Is there no need to copy swap for set function in order to guarantee strong exception safety? So absolutely, that's why we're doing swap in, I see. Let's see. So keep in mind for the set operation, the semantics there are simply to store the values in there. I wouldn't worry about it. It's way, way, way too much overhead to have strong exception safety guarantees for set. There's no requirement for strong exception safety guarantees for set. All you need are exception guarantees, the so-called weak exception guarantees, which says if an exception is thrown, I don't leak memory. So no, that's a very, very good question, and thank you for asking that. the answer is we don't require strong exception guarantees. In fact, if you look at C++ STL, you'll see that for the most part, it just supports weak exception guarantees, although when it's easy to also get strong exception guarantees, it does it using that idiom that we've talked about. But STL does not go out of its way to provide strong exception guarantees for all of its operations. For the obvious reason, it would be way too much overhead. Nobody would want to use STL if it did that. So great question. No, you don't need to do that, but that's a very insightful question. So another question, how do we delete the scoped array? Good question. So remember that there's two ways that a scoped array gets deleted. One way that the scoped array gets deleted is to have the destructor get called on it. And when the destructor gets called on it, the destructor will get called on it at the right time when the surrounding object, the array list, goes out of scope. At that point, the scoped array will automatically be destroyed and the memory will be deleted. That's sort of the most canonical way. But there's another way, and you have to use this other way all over the place in your code. Whenever you're doing ownership transfer, for example, and you want to be able to get rid of the left-hand side, well, you sure as heck can't call delete on scoped array. That would, again, that's just unfathomably destructive of your system. I can't even begin to tell you how bad that is. So instead, if you take a look at your scoped array, you'll see that there's a method in there that you implemented for assignment number 2 that deletes the memory. So go in and take a look at your assignment number 2, look carefully to see how it works. Hopefully you got it working based on the comments that I gave you for assignment number 2 and the frequently made mistakes discussion there. And you'll find that there's a method in scoped array that will manually delete the underlying memory. And manually, what I mean by manually is you have to explicitly call this method, and then under the hood, it does the delete. But it's part of the implementation of the method. And then you need to use that method when you need to clean up the scoped array. So I can't say much more than that without completely giving away the solution, but it's very simple, and it's all part of a pattern that we've talked about repeatedly. If you want to learn more about that pattern, take a look at the generic programming videos. There were 6 of them, and the first 2 showed you what not to do, and then the remaining, I think, versions 3 and 4 of those videos show you how to do it correctly, and then I think versions 5 and 6 talk about other things. But the 3rd and 4th video in our generic programming section will really show you how to do this correctly, and it shows you how to clean up scoped array-like holder objects. In our case, we were using unique pointer, but unique pointer is just a standardized way of doing the scoped array-like technique that we've been showing here in class. So that's a good question. Hopefully that'll get you on the right track. Okay, so those are the things I wanted to cover. Obviously, we will make this into a video, and you'll get a chance to watch this. And please make sure you go back and think carefully about everything you do. That's one of the key things that we're trying to get across in these assignments. These assignments are actually not very hard from a general sense, but they're tricky. And so you have to think very carefully about how they work. And the beauty is simplicity. And when you do assignment number 4, you'll actually be able to refactor parts of assignment number 3 quite dramatically to make them way, way, way better. So we'll talk about that in a second.